Alright, thanks for joining us in this video. This is the discussion of the retest review for Module 2B that deals with sequences in series as well as the binomial expansion. Okay, so for the assessment that we've had here, alright, you will be provided with the following formulas, and we need to understand the following formulas regarding an arithmetic sequence or series, a geometric sequence or series, as well as the summation for arithmetic sequences, for arithmetic series, or for geometric sequences or series. All right, an important thing to note with geometric sequences is that if I have an infinite series, I have a sum as long as that magnitude of my ratio is less than 1. So without further ado, let's discuss these solutions. Feel free to pause and the video as you need and ask questions where needed. So if we want to write the first 5 terms of each sequence, then we want to list out our terms separated by commas because commas describe a sequence for how we list our terms. Be sure that you start with n equals 1 unless you're told otherwise. So for this first one, 1 in the numerator, 2 to the first power in the denominator. Then 2 in the numerator, 2 to the second power. Then 3 in the numerator, 2 to the third power. 4 in the numerator, 2 to the fourth power, 5 in the numerator, right, and then 2 to the fifth power, which is 32. So we list out the 5 terms separated by commas. For the next one, if we look at the example over here, right, we see that we have starting with n equals 1. So if I have a sub 1, that's going to be 2 times negative 3 to the 0 power, which is going to be 2. So my first term is 2. I'm multiplying by negative 3 each time. So I go from 2 to negative 6, 18, negative 54, 162. And once again, separate your answers using commas. For number 3, I have a recursion formula. And so I have my recursion formula where a given term is going to be n times the previous term, with the first term being negative 1. So if I want my second term, that's going to be 2 times my first term, or 2 times negative 1. And so my first term is negative 1, the second term is negative 2. Then the third term is going to be 3 times that previous term, which is negative 6. Then 4 times that previous term, which is negative 24. Then 5 times that previous term, which is negative 120. And so I have the listing out of my values. For the next sequence, once again, we have a recursive definition. And if we look at what we have, our given term is going to be 2 plus the previous term, all divided by 2. So the second term is 2 plus the first term, all divided by 2. So 2 plus negative 6, all divided by 2, which is negative 2. Third term is 2 plus the second term divided by 2. Right, so we have negative 6 is the first term. Then we have negative 2. Then we have 0. Right, then the fourth term will be 2 plus 0 divided by 2, which is 1. Then we're going to have 2 plus 1 divided by 2, which is 3/2. All right, sequences separate with commas. Continuing, we want to find the explicit formula for the nth term of the following sequence. Right, and if we look at this sequence, we can see that we have a common difference of 4. So we're going to be adding 4 each time. We're going to have this arithmetic sequence. If I look at my setup, I can come to my formula for an arithmetic sequence that a sub n is the first term plus n minus 1 times the difference. And so I can come down and say, hey, I have, right, my first term, a sub 1 is equal to negative 3, and I have that common difference equals to 4. Okay. I could also set up and say, hey, well, if I know I have a common difference, I have 4 times n, And my first term when n equals 1 has to be -3, so I'm going to have -7. So either of those is okay. How many terms do I have in a sequence? I look and I see that there is a common difference of -3. So I have arithmetic with a common difference of -3. All right, once again, I know my formula to find the nth term. So -101 is the last term equals the first term plus n minus 1 times my common difference. And I can use technology to solve that. How could I use the technology? Well, we have an equation that we can solve, so I can come to my equation solver on my NumWorks, and I have -101 shift equals 4 plus parentheses, my counter -1, close parentheses, times -3, close parentheses, and if I go to solve that equation, I see that n is equal to 36. Next question, I want to find the sum of the first 20 terms, right? Arithmetic, we have a common difference of -5. We're subtracting 5 each time. So the sum of the first 20 terms, we have a formula for it. All right, once again, we can come over here and we can say, hey, here's the sum of the first terms if I don't know the last term. So substitute the values, 2 times my first term plus n minus 1 times my common difference, and I get -710 when I multiply that out with my calculator. I could just come to the calculation piece, right, and do all of that work. 20 divided by 2, right, parentheses, 2 times 12 plus 19 times -5, close parentheses, and I see I get that -710. Apologies that for this next problem, when this was printed, it seems like there is an error in the printing. And we can only determine an exact sum of an infinite geometric series if the common ratio is less than 1. All right. This common ratio is 3, so we can't find an infinite sum. So we adjusted this a little bit and we'll say, hey, I've got a first term of 5 and a last term of 3645. Okay, well, my common ratio is 3. 3645 divided by 5, my last term divided by my first term. That's going to be my ratio to the n minus 1 power. So I have 3 to the n minus 1 power is equal to 729. Once again, I can use technology to find my value, right, of n being 7, but that's not what I want. I need n equals 7. But let's show you how you get that. I go to my equation solver, and I have 3 raised to the, right, x minus 1 power, shift equals 729, and I see that if I solve that, I get 7 as my solution. So 7 is the solution. Then my sum of the first 7 terms, I have my formula to get that, which is the first term times the quantity 1 minus my ratio raised to the number of terms that I have, all divided by 1 minus the ratio. And when I do that, I get that total sum, which is 5,465. Okay. If that common ratio was less than 1 in magnitude, so for example, if we said find the sum of this infinite geometric series, we have a common ratio of 1/3, we have a first term of 5, and so our sum to infinity is the first term divided by 1 minus my ratio. When I put that in my calculator, I would get 7.5. For number 9, we're using technology, or we could try to do it without technology, but we want to evaluate. And to evaluate summation notation or sigma notation, I can go to my calculator to do my summation. So once again, on the NumWorks, I'll go to the toolbox, right? Go to calculus, where my summations are, and I have the sigma notation. My counter starts at 1, and my counter goes to 6, and I have 24 minus 3 times my counter, and that gives me the 81. Okay. For B, when I do the similar thing, I'd get 47 over 60. But of course, you could expand the series and say, hey, if I start my counter at 0, I'm going to have negative 1 to the 0 power divided by 1, which is 1. And then when k is equal to 1, I'm going to have negative 1 to the first power divided by 2. Then I'm going to have negative 1 to the second power divided by 3. Then I'm going to have negative 1 to the fourth power divided by 4. Then I'm going to have negative 1 to the third power, divided by 4. Then when k is equal to 4, I'm going to have negative 1 to the fourth power divided by 4 plus 1, which is 1/5. And I can see, right, that 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 gives me that 47 over 60. Okay. This particular series is called the alternating harmonic series. It's a common series that you may see when you do more advanced math applications. All right. So for number 10, determine the number of terms in the geometric sequences. So once again, sequence separated by commas, series separated by summations, plus, minus, or if it's alternating, right, plus, 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 if it's not alternating, or minus, minus, minus. So if I want to figure out the number of terms, I take my last term and I divide it by the first term if it's geometric. That's going to be my common ratio raised to the n minus 1 power. I can determine that my common ratio is 1/4, and so 1/4 to the n minus 1 power is 1 over 4096. Use technology, and I'll get n equals 7. All right. For B, the same idea. All right, and 405 divided by 5, that's going to be my common ratio raised to the n minus 1 power. So 3 to the n minus 1 is 81. You might recognize that 3 to the fourth power is 81, right? You might already know that from doing work. And so you say, hey, oh, I know that 3 to the fourth power is 81. So that means n minus 1 must be equal to 4. So n must be equal to 5. Okay. Then, applications of geometric sequences and series. An investment firm has a job opening with a salary of $30,000 for the first year, a very low salary in this day and age. Suppose that during the next 39 years there is a 5% raise each year plus 100% of the previous year's salary. Find the total compensation over the 40-year period. So we need to recognize that we have a geometric summation. And once again, that summation is going to be your first term times 1 minus the ratio to the nth power all over 1 minus the ratio. If I do that on my calculator, right, I've got 30,000. All right, 1 minus my ratio is 1.05 because it's 5% increase each year, so 1.05, and that's going to be raised to the 40th power because I have 40 years. Right, and then divide by 1 minus 1.05, and when I do that, I get that $3,623,993 and rounding 23 cents. Okay. For number 12, we're given the information that the second term of a geometric series sequence is -18. The fifth term is 2/3. We want to find the ratio and the value of the first term. So to get from the second term to the fifth term, I would need to multiply by my ratio 3 times. So I know that that fifth term divided by the second term is going to be the ratio to the third power. So that ratio to the third power is -1/27, and that means that the ratio is -1/3. So that second term, which is -18, is going to be the first term times my ratio. So my first term is going to be -18 divided by my ratio, which is -18 divided by -1/3. If I do that on my calculator, I have -18 divided by -1/3. That's nice about NumWorks. It sets up everything immediately, and that gives me a first term of 54. And lastly, our binomial expansion. right? For binomial expansions, it is important to understand Pascal's triangle. Pascal's triangle is going to build and help me with the coefficients of this binomial expansion. Right, so if I have something to the fourth power, my first coefficient is going to be 1. My next coefficient is 4. The binomial coefficient, then 6, then 4, then 1. If I have something raised to the fifth power, coefficient 1, coefficient 5, coefficient 10, binomial coefficient 10 again, binomial coefficient 5, binomial coefficient 1. There is a very nice symmetry to it. Then I would recommend that you use parentheses, all right? And so we have my first term to the fourth power. Then I'm going to subtract 1 from the power for the first term and add 1 to the power for the second term, all right? And then I go and subtract 1 from the power with a and -5, add 1 to the power, all right? Then subtract 1 to the power on the a, then add 1 to the power on the -5, and lastly, if I subtract 1 from the power on the a, I have a to the 0, and then -5 to the fourth power. If I multiply that out, I get a to the fourth minus 28 cubed plus 150a squared minus 500a plus 625. Be careful with the negative signs. So be careful. All right. And for the other expansion, I multiply the things out. All right, I have x to the fourth, 5 times 3 is 15. So I have x to the fifth, 15x to the fourth y, 90x cubed y squared, 270x squared y cubed, 405xy to the fourth, and the last term, 243y to the fifth. So that is the discussion of the retest review. If you have questions, please ask. Be careful with your technology. Thank you for your time. We'll see you again.